Good afternoon. It is Wednesday, November 9th, and with the internet down, I'm doing a recorded lesson. So today's lesson is 5.2, frequency tables, histograms, and frequency polygons. Just to pay attention, you will have an assignment that's due at the end of the day on the 14th, so that's Monday. I will have that assignment posted for you the next right after I finish this. I will be posting the assignment or getting it ready and posting it. Our exam is on the 25th. Okay, let's start. A frequency table, and we did a frequency table in our last example. We counted the frequency of the occurrence of events, of data. Now, generally, what we haven't done is looked at a set of intervals. So it doesn't always do to count just the particular exact data point. We look at how many data values sit inside of an interval of datas. And that's what we're going to look at today. So the data below depicts the amount of time in 45 minutes, or the time in minutes, that 20 middle school students spent on the computer each day, and we're going to arrange it in a frequency table. Now, it doesn't make sense, oh, how many times did students spend exactly 12 minutes or exactly 5 minutes? That's not what we're looking for. Is how many students spend around, somewhere between 0 and 10 minutes. That's what we're looking at, trying to have an idea where the data can be grouped in such a way that it becomes a little more meaningful. So if you have too many data intervals, you end up with data that there's just too much detail. And if you group them in intervals that are too wide, you end up with not enough information. So let's just think about our data. Here we start at 0 and we go to 60. So if I was to group it in intervals of 30, or sorry, not 30. So let's go interval, 1 to 30 and 31 to 60. That doesn't, right? We'd only have information about two pieces, and it's not enough detail to make it informative. But we don't want to do it in intervals of 1. So 1 minute, how many did 1 minute, how many did 2 minutes, and so on. So we want to find something that is in between those. And often you look at, well, from top to bottom, we've got 0 to 60. So that's our range. And if we do intervals of 10, that means the interval has a width of 10. That means we would have 6 or 7 intervals, which is what we're looking for. Something 6, 7, not too many more than that. Maybe 10 would be the most number of intervals you'd want in a histogram. So always start at 0 and go to 9. So if it's an interval of 10, you're starting at 0 to 9. That's 10, a measure of 10 or a width of 10. And then 10 to 19. Notice we do it so that there's no question about where a data point belongs. So if you go from 0 to 1 and from 0 to 10 and then from 10 to 20, does a 10 go in the first interval or the second? So you always divide the intervals so that there's no ambiguity about placement. So you make the interval wide enough so it's not too wide and not too narrow, so that you're having 6 or 7 intervals altogether. Let's see. Let's get back on track here. 20 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 to 69. So let's count the frequency. So I have 8, 0, right beside the 0 is a 5, and I have another 5. So if I was tallying, I would, each time I found one, I would do this, and for a total of 4. 10, let's use a different color. So 10 to 19, we have 10, 15, 12, and 15 again. And so that has an interval, or an interval with a frequency of 4. 20 to 22, or 29, we'll use green for that. 20, 25, and then 20 again. And so we have a frequency of 3. For 30 to 39, there's 32 and 30, and that's all. So we have a frequency of 2. Now let's cross them out. 40, so 45, 40, 45 again, and 47. That's 1, 2, 3, 4. So we have a frequency of 4. And then 50 to 59, we have 55 and 56 minutes. So that's a frequency of 2. And finally, we have just 60 left, so 1. So that gives us our frequency distribution table. Okay. Now we want to graph this. I'm going to set up my grid, and on here we have minutes. So it's time in minutes, and frequency, or the number of students. And so remember, we're going to split this from 0 to 9, 10 to 19, and so on. So this is 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 to 69. Now, it's important, because I'm doing this by hand and without a ruler, I haven't made those exactly the same width. They should be identical widths. Going up, I have a maximum of 4 students, so 1, 2, 3, 4. Always put a title in. So time students spend on computer. And so looking at, going back to our data, from 0 to 9, there were 4 students. And so we would go create or draw a bar that is the width of the interval and the height of the frequency. And then we have 4 again. Then we have 3. Two, and we have 4. Now, if you're doing one of these, I would encourage you to use a ruler so that you're not making it quite as messy as I am, but I want it to be reasonably visual, or acceptable visually. Okay, so we have our histogram. So a histogram is a bar graph where the bars touch, and the bars represent an interval of the type of data that you're collecting. Let's see. Oh, so I drew the histogram. Here's the definition for histogram. Histogram shows the frequency of data values on a table. Okay. A histogram differs from a bar graph in that the vertical columns are drawn with no spaces between them. And this is the definition of a histogram from the textbook. A graph of a frequency distribution in which equal intervals of value are marked on a horizontal axis. So the intervals are equal, and we did that. Marked on a horizontal axis, and the frequency associated with these intervals are indicated by areas of rectangles drawn. And so that's the data that we had, and we drew our histogram. I'm not going to redraw it. I forgot that I had a second sheet here. Let's look at a frequency polygon. So a frequency polygon is the graph of a frequency distribution produced by joining the midpoints of the interval. So it's the midpoints of the intervals using a straight line. So a graph by joining the middle top points of the columns of a frequency histogram. So it's not uncommon to have a frequency polygon attached over top of a histogram, but that's not always the case. So it's the middle, the point that we're connecting is the middle of the interval. So if I take the middle and find the middle of my interval, I can do that by averaging 0 plus 9 divided by 2. Oh, so the middle of my interval is 4.5. The middle of this interval would be 14.5 and 24.5 and so on all the way down. Now, if I was not graphing this over top of an interval, I would be plotting these points like so. So we plot the midpoint of the interval against the frequency, and then we join those points with vertical or with straight lines. Oops, so I start, and always drawing straight lines is a challenge for me on this. So there's a blue line. Always start at 0 and go across to the first point. Okay, I'm going to just try to draw straight lines. So this is a frequency polygon, like so. And that's the way we draw a frequency polygon. There can be a histogram underneath it or not. Doesn't matter. Now we want to compare histograms. This is on page 246 in the textbook. The magnitude of an earthquake is measured using the Richter scale. Examine the histograms for the frequency of earthquakes magnitudes in Canada from 2005 to 2009. Which of these years could have had the most damage from earthquakes? Well, so the first thing we need to do is look at the effect. If you have a magnitude that's less than 3, it's not hardly even felt. from 3 to 9, and notice again we have those intervals and there's no overlap. There's no damage, and it's just a feels like a passing truck. And if you're in a vehicle, you won't even feel it because you're driving and you already have motion. From 4 to 4.9, it's felt by people and unstable objects will move. So you might have something that's attached to the top of the, not attached on the table, it might move around. Then at 5, you have considerable damage to weak buildings. So here's where at 5 we start to see that we have damage and some structural damage. And then it starts to have the collapse of ordinary buildings. So that starts to be pretty significant. And after 7, we start to have loss of life and full collapse of buildings. Okay. So how are we going to define or decide which year has the most damage? Well, we want to count the frequency of earthquakes greater than 5. So 5 and greater. So here, 5 and greater would have 3. Here, 5 and greater would have 3 as well. Here, 5 and greater is 3. And then all of a sudden in 2008, we have, this is 5 and 3, 5 and 4. So we have 9 earthquakes that would cause damage. And in 2009, there were 3 and 1, so 4. So clearly, we had the most damage in 2008. Also, if we look at 4, where unstable objects are moving, so if you consider damage of something that might, plates that might fall off, or cupboard, if your building is shaking, then maybe things come out of off bookshelves and stuff. You'll see that that's actually quite high as well. That's as many as 16. Okay, so that's frequency polygons and histograms. I want you to do some practice. Here's your practice pages. Remember that if you have questions, come with them on Monday. We will take time to answer any of your questions, and you can work. And just ignore this. This is from another when I didn't have them split up. Okay. Anyway, have yourself a great long weekend, and I will talk to you on Monday. Bye now.